Hello, fifth graders. So today we're going to begin our last topic of this whole entire topic, and it's about dividing decimals by decimals, okay? So we've talked about estimating decimals. We've learned how to divide a decimal by a one-digit whole number. We've learned how to divide a decimal or a whole number by a two-digit whole number. Now, my question is now, what do we do if the dividend is a decimal and also the divisor is a decimal? And that's what we're going to be talking about today when the divisor is a decimal. It's really important to know when dividing decimals, the divisor cannot be a decimal. So this number right here is not allowed to be a decimal when you're doing the division, all right? It will just make your life 10 times harder if it is. So our job is to try to get that decimal and try to change it into something else. And now you may be asking, Ms. Rothstein, how can I change this divisor without actually changing the problem? And that's what I'm going to go over today in this lesson, okay? So just remember, this divisor can never be a decimal. So when we multiply the divisor in this problem, so this problem right here is 23 and 56 hundredths divided by 4 hundredths. This 4 hundredths is a decimal, but we cannot have it be a decimal. So we need to think of what we can do to get rid of that decimal. So what can we multiply this divisor by in order to not have a decimal anymore? Think about powers of 10. What can we multiply 4 hundredths by so that somehow we shift that number and it doesn't have a decimal anymore? Well, we can multiply it by 100, okay? And again, let me just flash back to when we multiply by powers of 10. If we have the number 4 hundredths, okay, and we're multiplying by 100, we're going towards the bigger numbers 2 times. So we shift it once, and then we shift it again. And now this 4, yes, there's a decimal there, but technically it's really just 4 wholes. So by multiplying it by 100, we got rid of the decimal, and now it's just 4, okay? But we talked about this. You can't just change one part of your problem. Just like fractions, if you look at this example of equivalent fractions, 2/3, we multiply the top by 10 and the bottom by 10 and get 20/30ths. Okay, we have to do the same thing to the top and bottom. So if we multiplied this number by 100, what do you think we have to do to 23 and 56 hundredths? We also have to multiply that number by 100. Okay, so multiplying this number by 100, again, you can use this to help you. You can also think about it really just shifting twice. Okay, so if we were to use this, all right, it's 23 and 56 hundredths shifted once and shifted twice. Okay, so we also multiplied this number by 100, so now it's just 2,356. So our problem is no longer this. We multiplied both of these by 100 because we couldn't let the divisor stay a decimal. So basically what we did is we shifted it twice. Okay, if you want to think about it shifting twice, we're multiplying by 100. We shifted it twice, so it's just 4. But again, if you think about equivalent fractions, you have to shift this decimal twice as well. You have to keep it the same. If you only change one, the whole entire problem is different. So now we really have 2,356 divided by 4. And now we can complete this problem just like a regular division problem, okay? And if you're still confused at why it's still the same, again, refer back to equivalent fractions, okay? 2/3 is the same thing as 20/30ths because we multiplied the top numerator and the bottom denominator by the same number. And that's basically what we did over here. We multiply both of those by the exact same number. So now we can complete this problem. 4 goes into 23 5 times, you get 20. Subtract, you get 3. Bring down the 5, you get 5. 4 goes into 35 8 times to get 32. Subtract, we get 3. Bring down the 6. 4 goes into 36 9 times to get 0. So our final answer is 589. All right, so let's try another example. Again, this is a process that you just have to get used to for this. You gotta erase this so we can use this again if we need to. All right, so our problem is 73 and 2/10, divided by 6/10. Okay, so again, what can we multiply this divisor by in order for it to not have a decimal anymore? Basically, we want to shift it one time this way. So what would that require? If you look back at these problems, shifting it twice was multiplying it by 100. So shifting it once is multiplying it by 10. And again, we can look at that. Multiply by 10, we're going towards the bigger numbers once. It would go like that. We get 6, okay? Now, 6 is our divisor, which is perfect, but we can't leave 73 and 2/10 there because we didn't do the same thing to the dividend. You need to make sure you also multiply the dividend by 10. All right, so multiplying the dividend by 10 again, if you wanted to use this chart to help you. The dividend is 73 and 2/10. You shift it once towards the bigger numbers because we're multiplying by 10. It would be 732. And again, that's the same thing as having this decimal go that way once to make it 732. All right, so now the equivalent division problem is just 732 divided by 6. Okay, and now what I want you to do here is to estimate this problem. All right, so we can keep the 6 as 6. We can look at these first two digits, 73. Okay, and I know 6 times 12 is 72, so I can make this 720. 72 divided by 6 is 12. Add the 0 to 120. All right, so now I can do 732 divided by 6 and see what I get as my answer. Okay, so again, this problem, guys, is identical to this problem. Think about them just really as equivalent fractions. Okay, all we did, another way to write this is to do 73 and 2/10 divided by 6/10 and just to multiply the top and bottom by 10, and we would get that. So all we're really doing is just making an equivalent fraction. All right, so let's rewrite this problem. Let's solve it. 6 goes into 7 once. You get 6. You subtract, get 1. Bring down the 3. 6 goes into 13 2 times to get 12. Get 1. Bring down the 2. 6 goes into 12 twice to get 12. Okay, now, since the decimal's technically here, the decimal's there, so it's really just 122. All right, now this last one, what I want you to do is to complete this by yourself. See what you need to do. Okay, this is a little different. Okay, so we have 2 8/10 divided by 7/100. So we need to shift this decimal in the 7/100 this way so that we have that decimal at the end, so it's just a 7. So what is that technically multiplying by? We're getting a bigger number. We're shifting it twice. It wouldn't be multiplied by 100. Okay, shifting it twice this way will give you 7. All right, now, again, whatever we do to one, we have to do to the other. Okay, so we multiply this by 100. So that requires, again, you can either use this template if you want, or if you want to just shift just like how you shifted this twice, you would shift this twice. Okay, now the decimal is here, meaning that we have a blank spot. What do we put in that blank spot? 280. All right, so now our problem is 280 divided by 7. And that's actually a basic fact, okay? That is, we can keep it as 280 and 7 because 28 divided by 7 is 4 and 0. So we actually just found the answer without even doing the long division. But let's do the long division just to double check. 280 divided by 7. 7 goes into 28 4 times. You get 28. Get 0. Bring down the 0. 7 goes into 0 0 times to get 0. So our answer is 40. Okay? So the big thing with this is you just need to make sure, this is a really important fact, that the divisor cannot be a decimal. So if you're left in a situation where the divisor is a decimal, you need to shift that decimal or multiply by a certain number. And whatever you do, whether you multiply it by 100 or shift it 3 times, whatever you do to that divisor, you need to do the exact same thing to the dividend, because you're creating an equivalent problem. If you don't do the same thing, it's not an equivalent problem, and that's when your division problem gets all messed up. All right? So just make sure, if you got anything from this, whatever you do to one, you have to do to the other. If you shift one twice, you have to shift the other twice. If you shift it 5 times, you have to shift the other one 5 times. It has to be the exact same. All right? So what I am going to do is, in your Google Classroom, there's going to be a little review of these concepts. Okay? You're going to practice shifting the decimal, practice rewriting your new equivalent division problem. All right? So just make sure you practice that. If you have any questions, please let me know. And have a wonderful day, 5th grade. Bye.